Hi, in this video, we are going to discuss about projectile motion. Let's talk about projectile motion. So projectile motion is simply that when a body is projected with certain initial velocity and allowed to fall under the action of gravity, such type of motion is known as projectile motion. So right, when a body is projected with some initial velocity or with some velocity and allowed to fall under the action of gravity. We have got basically two types of projectile motion. One is the horizontal projectile motion, and the another type is angular projectile motion. So horizontal projectile motion is simply that when a body is projected in such a way that which makes zero angle while projecting with the horizontal, while as angular projectile motion is that of motion which is projected in such a way that it makes certain angle with respect with horizontal surface. So we are specifically going to talk about horizontal projectile motion. Now let's talk about horizontal projectile motion. Sorry, angular projectile motion. Angular projectile motion. Now, what is this angular projectile motion? It's simply that if suppose that we have this coordinate x and y coordinate, which is the horizontal surface and this is the vertical surface. If I'm projecting a body by giving certain velocity v, let us suppose that I am projecting a body by giving certain velocity v, initial velocity v, and it makes certain angle theta with respect to horizontal, and I allow it to fall under the action of gravity. So this type of motion is known as angular projectile motion when it makes certain angle with respect to horizontal. Now, when I project this body with respect to horizontal at certain angle theta, this velocity v has got two components. One will be the horizontal component, another will be the vertical component of velocity. Now this horizontal component, as it makes angle theta with the horizontal, so this horizontal component of this velocity will be v cos of theta, and similarly the vertical component of this velocity will be v sine of theta. Now, as we see here that along this horizontal direction, there is no force, external force acting on the body. Thus, this horizontal component of the velocity will remain constant throughout the journey, which means that if Vx represents the horizontal component of the velocity, it is equal to v cos of theta, and this velocity will remain constant throughout the motion of the body. But if you'll see this vertical component, which is v sine of theta, this v sine of theta goes on changing because of the action of gravity. So therefore, this vertical component of the, if I say Vy is the vertical component of velocity, which is v sine of theta, it would be changing due to the action of gravity. So therefore, along the path of this body, it will be acting, there will be two components. One would be the v cos of theta, which is the horizontal component. And similarly, there will be v sine of theta throughout the entire journey. Similarly, so this will be v cos of theta, and this will be v sine of theta. Now, this v sine of theta, as the body, when the body is going in upward direction and it reached the maximum height, and because of the action of the gravity, first this velocity goes on decreasing, which is a vertical component, till it reaches the maximum height, where the vertical component, which is the Vy, vertical component of the velocity, become a 0 at the maximum height, at h max. And after this point, it will be like this velocity goes on increasing, finally reach to ground and becomes 0. Now at every point there will be force of gravitation, or we can say acceleration in the body will be because of the gravity. So we will write this acceleration will be minus g, because the acceleration, the gravity is acting downwards at every point of the body. So therefore the A would be here minus g. Now, if we say that this horizontal component is constant, therefore the acceleration along the horizontal direction will be 0, and the acceleration along the y direction would be because of the acceleration will be due to the gravity. So we'll take it as minus g, because the direction is opposite to the direction of the motion. So now, if I'll say that what could be the displacement of the body along the vertical and the horizontal direction, so I will write the displacement equation, which is S is equal to ut plus half of at square. Now, if y is the displacement along the vertical direction, and the initial velocity along the vertical direction is, which is v sine of theta, t is the time, plus 1/2, the acceleration is the minus g, then t square. So therefore we'll get y is equal to v sine of theta into t minus 1/2 of gt square. Let me keep this equation number first. Similarly, what would be the displacement along the x direction? The displacement will be, again, here the initial velocity is v cos of theta, and then t time plus 1/2. Since the acceleration along the x-axis or the horizontal component is 0, so acceleration will be 0 into t square. So we will get displacement along the horizontal direction will be, or around the x-axis will be, v cos of theta into t. So this will be the displacement along horizontal direction. Now, if I'll find out the value of t from this equation, I'll get t is equal to x upon v cos of theta. Let me keep this equation number 3rd, and I'll use this equation, number 3rd in equation number 1st. So if I'll use this in the equation number 1st, what I'll get y is equal to v sine of theta, and instead of t in the equation 1st, I'll use x upon v cos of theta, then minus 1/2 into g, and out of t square, I'll write x upon v cos of theta whole square. So if I'll further solve this equation, I'll get y is equal to v sine cos of theta. Sine theta upon cos of theta is tan theta, and this v and v will cancel each other. So I'll get, instead of the c, I'll get x tan of theta, then minus 1/2 into g, x square upon v square cos square theta. So here, y will be equal to x tan of theta, then minus g upon 2v square cos square theta into x square. Now, from this equation, if I, for a given value of this v, for a given value of this v and the theta, we can find out the value, this, for the given value of this v and the theta. So we can find out the value of this equation. We'll get y is equal to, in the form of x, then minus x. This will become a quadratic equation. So therefore, for a given value, then after, for a given value of x, we can find out the displacement along the y-axis. So here, this tan of theta will take, this tan of theta is a constant term. If I know the angle, so it will get as, let us suppose that this tan of theta is A. Similarly, G is constant, 2 is constant, V is the initial velocity which will be constant, and similarly cos of theta, we will keep this as equal to B because both are constants. So if I place this equation, the value in the above equation get AX minus BX square, which signifies that this is the equation of the parabola. So which signifies that the path followed by, so this is the equation of parabola. So which signifies that, which means that the path followed by the projectile is parabolic. Or in simple words, we would say that this path followed we call this as trajectory. So in simple words, we can write the trajectory of the projectile is always parabolic. So therefore, this equation represents or signifies that the path followed by the projectile motion is always parabolic. Now let's talk about the time of flight. So what is this time of flight? Time of flight is the time for which this particular body remains in the flight. Or simpler, we would say that the maximum time for which our body remains in the air. So how we'll calculate this time of flight? As we know that the equation for the displacement along the vertical direction is y is equal to v sine of theta into t minus 1 by 2 gt square. So if I suppose that this is the point O and point P, so they're the 2 points where this projectile is at the surface of Earth, and in this case, both the points O and P, so at O and P, the vertical displacement, which is y, is equal to 0. So therefore, if I'll place y0 in the above equation, I'll get 0 is equal to v sine of theta into t minus half of gt square. And I'll get this further equation. This is v sine of theta into t is equal to 1 half of gt square. T and t will cancel each other. I'll get the value of t is equal to, from this equation, 2 times v sine of theta upon g. So which is nothing but it is the time of equation for the time of flight. So this is the equation of time of flight. So from this equation, we can find out for how much time our body remains in the flight from the time it is being projected with certain velocity to the time it comes back to the ground at point P. Now let's talk about, so if I need to find out the maximum, or you can say the time taken by a body to reach the maximum height. So how I'll find this value? As we know that from the symmetry of this parabola, the time it will take to reach this highest point, the same time it will take to reach back to the ground. So therefore, the time to reach maximum height, if I write Tm, which is the time to reach maximum height, it would be equal to half of the time of flight, and that would be equal to v sine of theta upon g, which is the time to reach the maximum height. Okay, now let's talk about the maximum value of maximum height let's talk about the value of maximum height attained by the projectile during its motion. So how I'll find this maximum height? As we know that, again, we can find out this from the vertical component of the velocity. So this is angle theta, projected velocity v. This would be v cos of theta, the horizontal component, and v sine of theta, the vertical component. Similarly, it will go on. And here at this point, the vertical component would be 0. This is the maximum height at which the vertical component would be 0. So therefore, if I'll find out the displacement equation, this will be y is equal to v sine of theta into t minus half of gt square. Why this t? This t is the time which the body takes to reach this maximum height. So this t is here tm, which is the time which the body takes to reach the maximum height, and its value is v sine of theta upon g. So if I place this value in the above equation, what I'll get, y is equal to v sine of theta into v sine of theta upon g. Similarly, minus 1/2 of g, then v sine of theta upon g ka whole square. So if I further solve this equation, I'll get y is equal to v square sine square theta upon g minus half of g, then v square sine square theta upon g square. This g and g will cancel each other, and what we'll get? We'll get y is equal to v square sine square theta upon g minus half of v square sine square theta upon g. So which means that v square sine theta upon g minus half of v square sine square theta upon g, we will get this, which vertical displacement is nothing but it is the maximum height. So h maximum will be equal to 1/2 v square sine square theta upon g. In simple words, I will write as v square sine square theta upon 2g. So which is the equation for maximum height attained by a body during its motion, during its projectile motion. Similarly, we can find out the equation for horizontal range. So what is horizontal range? Horizontal range is simply the horizontal distance or the maximum horizontal displacement that caused by the body during its projectile motion. Or in simpler words, I would say that when the body is projected with certain initial velocity v, making of theta with the horizontal, the distance or the displacement that it causes from the time it is projected to the point it comes back to the ground, which is OP ground. This OP distance is the horizontal distance that it covers during its projectile motion, and this is known as horizontal range. As we know that, so this is the v sine of theta, similarly v cos of theta. So in this here, if we have to find out the horizontal range, for this we need to use the horizontal displacement equation. As we know that x is equal to, x is the horizontal displacement, it is equal to v cos of theta into t. As we know, then we have got minus half of gt square, but in this case, there is no acceleration along the x-axis or along the horizontal direction, so the acceleration would be 0. So you'll get x is equal to v cos of t. So what is this t? T is the time of flight. Here, because it takes the entire time to, it takes entire time from the point it is being projected to the point it comes back to ground. So this is the total time of flight. And we know that the time of flight is equal to 2 times v sine of theta upon g. So if I'll place the value of t in the above equation, I'll get x is equal to, which is nothing but the horizontal range, is equal to v cos of theta. And instead of t, I'll use 2v sine of theta upon g. So if I'll solve this equation, I'll get 2 times v square sine theta, then we have got cos theta upon g. And instead of this value, we know that we'll get here v square. Okay, we know there's a formula which is sine of 2 theta is equal 2 times sine of theta into cos of theta. So we can keep this equation as it is, but if we want to solve it further, we can. We can write, instead of this 2 times sine of theta cos of theta, we can write sine of 2 theta upon g, so which is the value of horizontal range. And remember this thing, that at the angle of, as we know that sine has got the maximum value at an angle of theta is equal to 90 degree. So which is the value of 1, as the value of the sine lies between the -1 and the 1. So 1 is the maximum value of the sine theta, and that lies at an angle of 90 degree. So therefore, this theta needs to be equal to what? 45 degree in order to become this sine 90, because 2 times 49 is what? Sine 90. So at angle of, at theta 45 degree, there is a range would always be maximum. So maximum value of the range for any body projected with certain angle would be at the angle of 45 degree. So thanks for today. This is all about today's lecture. Thank you.